Hello, this is Quan Lu, and this is my Lab 3 for physics. Let's first begin with the purpose of our experiments. We're going to be using a small bar magnet and exploring magnetic fields and the distance dependence of the magnetic fields using experimental observations and a computational model. The experimental model will measure the magnetic field using a magnetometer, and the computational model will compute the magnetic field by applying the Biot-Savart law. At the bottom of the page, you can see a preview of some of our main results, and our observed magnetic field was quite similar to the predicted magnetic field. So here are some of the fundamental principles used for this. We got the Biot-Savart law, magnetic field caused by a magnetic dipole, magnetic field perpendicular to a dipole, magnetic field parallel to a dipole, and the distance dependence of a magnetic field. These are all just formulas relating to magnetic fields. And our assumption that we made is that the bar magnet is going to act as a magnetic dipole so that we can apply the Biot-Savart law. Let's look at the experimental setup for our system. We have the bar magnet and the magnetometer, and our surroundings are everything else. The initial conditions are that just the bar magnet, which is producing a magnetic field, and we find the magnetometer in the phone by using this yardstick and sliding it back and forth until we find some place on the phone that the X value is maximized, and then we do the same thing similarly for the Y value, and using pieces of tape we can find the intersection point of where the X is max and the Y is maxed, and that has to be where the magnetometer is. For determining the magnetic field on axis, we first made sure that the phone was aligned to the Earth's north-south axis, and a meter stick was in place along the phone's edge, and the magnetic field was measured by the magnetometer at multiple distances from the bar magnet. The data were linearized using the natural log, and here's the graph, and here's the data. We used the equation generated from the graph of the on-axis magnetic field measurements to compute the magnetic field of the bar magnet at a given observation point, and then rearranged the equation for the magnetic field at a parallel observation location to solve for the magnetic dipole moment of the bar magnet, and this value came out to be 3.11. For the off-axis measurements, we move the magnetometer along the meter stick to find a distance d for which the net magnetic field had a magnitude of 100 microtesla. We then add a meter stick perpendicular to the first one, and we moved our phone up along the second ruler so that the sensor was now a distance of d perp from the horizontal ruler, and we then used the magnetometer to determine the X, Y, and Z components of the net magnetic field at this location. We corrected the Y component by subtracting the Earth's magnetic field from the total magnetic field measured for that Y component. And then here's the computational model we generate for our data. Here we have the same equation that we used earlier, and we're just computing it. And we insert this mu mag that we found earlier, and here's the next segment of code, and we use this to calculate the magnetic field at 45-degree off-axis observation locations. Here's the off-axis location, and the four surrounding ones are the parallel locations. Or no, sorry, these are the perpendicular locations, and the orange is the parallel. This off-axis magnetic field is quite similar to what we observed, and although we might have had some sources of error in the other magnetic electronic items nearby, which could be interfering with the phone's magnetometer, and we could have calculated the location of the magnetometer incorrectly, or we could have used the magnetometer even though it's the phone's magnetometer, even though it might be less reliable than a scientific instrument. So what if we hadn't oriented our experiment to compensate for magnetic north and had instead laid out our meter stick at some intermediate angle with respect to the Earth's magnetic field. The results would have changed by skewing our data, resulting in inaccuracy since the Earth's magnetic field would have interfered with the bar magnet readings. And if we were to stick two identical magnets together end to end and run the experiment again, we would expect the measurements to roughly double in magnitude, but of course still stay in the same direction.
Thank you so much for watching.